Rational and irrational numbers. This is a digital lesson. And the lesson starts with explaining that a rational number is a number that can be expressed as a fraction or a ratio. So for example, this decimal can be expressed as a fraction 3/5. 75/100ths can be expressed as 3/4. An irrational number cannot be written as a fraction or a decimal. So for example, a decimal that goes on forever and does not repeat, does not terminate. Pi is an example of that. Or a square root or cube root that cannot be simplified to a whole number. So it explains that a little bit more detail in the next slide. Next two slides. Now here it explains that natural numbers, whole numbers, and integers are all rational because they can all be expressed as ratios. So on slide 5, students are going to just type in each of these to show that these are all rational numbers, all of these integers. So you're going to have a variety of answers from the students. So this one could be 27/3, which equals 9. So they can show that 9 can be expressed as a fraction. -8 could be expressed as -8/1. So you're going to have some different answers here. So that just makes it clear to the students that all of these are rational because we can write them as fractions. And then these decimals can be expressed also as fractions, and they're going to do that on the next slide. So this one could be 2/5 or 4/10. This one could be 1/4. These can all be expressed as fractions. So students are going to type those in. And then repeating decimals are rational because we can convert them to fractions. And we're going to show students how to do that. But before we do that, we're going to show that all of these fractions, these three, can be converted to repeating decimals. And students are just going to use their calculator, 1 divided by 9, and then type in their answer, 5 divided by 6, and so on. And now we're going to show students how to change a repeating decimal to a fraction. And there are 6 different steps. So students are just going to follow the steps. They're going to get a little practice doing this, changing a repeating decimal to a fraction so we can show that they are rational. So they're just going to follow the steps. I won't go through each one here, but it's pretty much set out for the students, and they can refer back to slide 12 or slide 10 and 11 for the steps, and they're just going to type in each step. Now decimals are irrational if they go on forever, do not terminate or repeat. And then here's some examples of square roots and cube roots which are irrational because we can't simplify them to whole numbers. Now this one would be rational, the square root of 36, because we know it's 6. So this one is rational, these are not. So they're going to go through in slide 17 and they're just going to put an X in the box next to each irrational square root or cube root. So square root of 10, square root of 30. Now they also need to know that if you have an irrational number and you multiply or divide it by a rational number, it's still going to remain irrational. It's just a rule you want to go over with the students. Now here they're going to place an X next to each irrational number. Square root of 6. This one, the decimal that goes on forever, doesn't repeat. And then here we've got a square root that cannot be simplified to a whole number. Now comparing and ordering irrational square roots. So where would an irrational square root go on the number line? So this shows students how to do that. So for example, we have the square root of 28. It's kind of hard to place on the number line just by looking at it, but we know it's between these two perfect squares, square root of 25 and the square root of 36. So we know it's between 5 and 6 on the number line. So on the next slide, students are just going to be writing in these perfect squares that are on each side of these irrational square roots. So for example, this one would be square root of 6. It'd be between the square root of 64 and the square root of 81. So it would be between 8 and 9 on the number line. And they're going to do that with the other 3. And then on slide 22, we're going to be typing in the whole numbers that would be on either side of these irrational square roots. So here we would have square root of 25, which would be 5, and the square root of 36, which would be 6. So it would be between these two numbers on the number line, and square root of 35 is close to the square root of 36, so it's going to be closer to 6 on the number line. So they're going to type in the whole numbers that this irrational square root would be in between, and then move this circle just by clicking and holding on the edge. Move it to show the square root that's closer, or the whole number that's closer. And then on this last slide, students are going to be moving these 4 boxes, and they're going to move them into place to show where they would go in the number line. So for example, square root of 54. That's going to be between square root of 49, which would be 7, and the square root of 64, which would be 8. So is it closer to 49 or 64? It's closer to 49, so it's going to be closer to 7 on the number line. So then they're going to place the other 3 boxes where they would go on the number line, and then put a circle around the whole number that's closer. So that is a digital lesson on rational and irrational numbers.